Hello guys. So in the last video I showed you how to use the basic functions in the Desmos application. So today we are going to continue by looking up at some functions that you can actually draw and what the Desmos application automatically gives you when you enter them. So let's start by tapping on the Desmos icon so you can open the application, and now you are going to introduce a few functions that you may be familiar with. First of all, you need to be aware that Desmos, just like any high school student, starts by learning that you can use Y to show a function, but it's a lot better to use F. Now we're going to show several different functions here, so we are going to number them. This is going to be f1 of x, and the first one that we are going to show is the basic linear function. F1 of x equals x. Now you can see that Desmos doesn't put any restrictions on the domain of the function. Later on in a next video, we're going to show you how to restrict the function to certain values. Right now we're just going to make this go away, and we will do that by tapping on the little circle to the left. That just makes everything invisible. And we're going to make a second function. Let's call it f2. You don't have to do anything other than just tap the number and it comes as a subscript already. So f2 of x is equal to, and we need a quadratic now, so x, and this little button gives you the square. I want you to notice two things. First, that Desmos decides on its own on the different colors that it's going to give your functions. And second, that you don't need to do anything to the 2 if you use this little button, which basically makes everything squared. Okay, so this is your quadratic function. As you can see, it's a parabola. Nothing terribly complicated about that. But what happens if you need another exponent, just not the 2? So let's make f3, function f3 of x, equal to x cubed. How are you going to draw a cubic function? Well, you tap the x as always, and then to the right of the squared you have this little button that just puts you in the position of the exponent, and you can choose the number that it best fits you. So that will be x cubed. If you reduce the y-axis so that it looks a little shorter vertically, then you can see that it's a cubic function. Let's go back to the original one because that's the actual shape of the cubic function. And let's just make it disappear. We'll continue with another much more interesting function. What happens with the basic rational function? What happens when you have a division? So let's call this f4 of x, and the basic rational function is just dividing a number like the number 1 into the variable x. Now I'm gonna show you this in the full screen so you can actually see what's going to happen. First of all, notice that on the right side of the axis you have positive values of y because you're dividing 1 into a positive value. On the left side you have negative values for y because you're dividing 1 into a negative x. But as you go away to more negative numbers or to more positive numbers, logically the division gives you smaller and smaller values. So you get closer and closer to the x-axis because the y has a very small value. Let's go back to the home and see what happens when you are very close to the 0 in the x-axis. As you can see by the numbers, that is just the point 2 for x and 0.5 for y. If you're here, that's 1 comma 1. If you're here, that's 0.5 comma 2. It seems I can't make it appear, but anyway, the point is that the closer you get to this origin, the smaller the value of x, the higher the value of y. And so your function climbs up and up and up because you're getting very high values for y. But on the other side, on the negative side, things happen exactly the opposite way. You take numbers that are very close to 0 on the negative side and you get very high values of y but negative. And so if you look at it from a distance, what you're seeing is that this function is getting very close to the y-axis, but it never quite touches it because you can never assign a 0 there. Your function 1 over x doesn't include 0 in the domain. So that's your basic rational function. Now, what happens when instead of a division, what you have is a square root, or any kind of root for that matter? Well, we are naming that f5 of x, and just to keep it simple, we are going to use the basic square root of x. And this is what happens. As you may see, Desmos automatically avoids all of the negative x's. You cannot have a value for x that is on the negative side because you cannot take the square root of a negative number. So automatically, Desmos takes only the valid domain of the function from 0 to positive infinity. And the basic radical function looks like this. It doesn't grow quite as much as a linear function because for x equals 1 you get y equals 1, but for x equals 4 you only get y equals 2. For x equals 9 you get y equals 3, and so on. Y grows as the square root of x. So that's your radical function over there. And now we are going to work on something a little bit more interesting. You may see that right below the open parenthesis key you have this double bar that in math indicates absolute value. Let's do that as f6. f6 of x is equal to the absolute value of x. And lo and behold, look at the function. Now, it will be very interesting to relate this function to the original linear function. Look at it. If you make the absolute value go away, then all you have is your linear function in red. If you make the absolute value function visible again, you can see that on the positive side, they coincide completely. On the negative side, what you have is the reflection, because the absolute value only gives you positive values or zero. So it kind of bends everything so that it's above the x-axis. The same is going to happen when you take more complicated functions. But then let's just make this one disappear, and that's gonna be your absolute value function, or at least the basic one. You can combine them, of course, with more complicated functions. By the same token, we can actually have functions that are more complicated. Let's, let's call this f7. And f7 of x is a function that you may be acquainted with, but if you look at the keyboard, it's not going to be there. We have run out of options here, but there is a button at the right that says functions, and it gives you an interesting list. There are trigonometric functions, which we'll study later, statistical functions, which are of no use to us at the moment, and there is this miscellanea. Now, one of the functions that we want to talk about is called the floor function. And what this floor function gives you is an integer that is right below the real number that you are working with. So if I take the floor function of x, what I get is a very interesting graph, because what this function does is just take the integer part of your number. Say, for example, if your number is something like 1.7 over here, then the integer part is just 1. And that's why your function is here. Now, the value is the same for 1.5, just 1. But if you have a number like 2.1 over here, then the integer part is 2. And so, depending on the value of the real number, you are making something like a step function, because it looks like a staircase. Okay, if you look at it from a farther away perspective, it does look like a stair where all the values are integers. So that's a floor function. Takes the smaller integer that is the greatest you can have. It's a little more complicated on the negative side, because if you have a number like negative 1.5 over here, the integer that is precisely to the left is negative 2, and so your value is negative 2. So dealing with the integer function floor is a little more complicated. We can combine that, or compare it rather, with f8. We are going to name that the ceiling function, and I'm writing it because I want you to notice that you can actually type them. You can take the alphabetic keyboard here and type ceiling, oh sorry, just ceil of x. And as you can see, maybe it's a little hard at this point, but you can enlarge it. What it does is that it takes all the steps and it moves them one step up. See, this is the floor function, this is the ceiling function. For the floor function, between 0 and 1, you're at 0. For the ceiling function, between 0 and 1, you're at 1. One step above, because you're taking the bigger integer, not the smaller one. So these are a few functions that you can actually work with, and like I was telling you, the important part here is that the Desmos application automatically defines what the domain is and how you can graph them, and in the next video we are going to show how you can combine them in different situations. So that's it for right now. Bye bye.